Welcome to the first module of our comprehensive AI development course. In this module, we'll lay the groundwork for understanding artificial intelligence and machine learning. We'll start with the very basics. What exactly is AI, and how did we get to where we are today? So, what is artificial intelligence? At its core, AI refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. The ideal characteristic of AI is its ability to rationalize and take actions that have the best chance of achieving a specific goal. The concept of intelligent machines isn't new. The roots of AI can be traced back to ancient myths and philosophical inquiries about artificial beings. However, the modern field of AI began in the mid-20th century. Key milestones include: in 1950, Alan Turing proposes the Turing test. In 1956, the term artificial intelligence was coined at the Dartmouth workshop. In the 1980s, expert systems gained popularity. In 1997, IBM's Deep Blue defeats world chess champion Garry Kasparov. In 2011, IBM Watson wins Jeopardy! In 2012, the deep learning revolution begins with AlexNet. In 2016, AlphaGo defeats world Go champion Lee Sedol. From 2022 to present, we've seen the rise of generative AI and large language models. Now that we have a grasp of what AI is and its history, let's delve into the different categories of AI. This classification helps us understand the current capabilities of AI and what the future might hold. The vast majority of AI we encounter today falls under the category of narrow AI, also known as artificial narrow intelligence or ANI. This type of AI is designed for a specific task and operates within a limited context. Cannot perform tasks beyond its programming. Examples include Siri, chess programs, and recommendation systems. The next level is general AI, or artificial general intelligence, AGI. This is a theoretical AI that would possess the ability to understand, learn, and apply intelligence across any intellectual task that a human can perform. AGI remains theoretical and has not yet been achieved. Beyond AGI lies Super AI, or Artificial Superintelligence, ASI. This is a hypothetical AI that would surpass human intelligence in virtually every field, including creativity, wisdom, and social skills. ASI is purely speculative at this point and is the subject of philosophical debate. Now, let's dive into machine learning, which is a core component of modern AI. Machine learning is essentially the science of getting computers to act without being explicitly programmed. It's about enabling systems to learn from data, identify patterns, and make decisions with minimal human intervention. Machine learning is a subset of AI that enables systems to learn from data, identify patterns, and make decisions with minimal human intervention. There are three main types of machine learning. Supervised learning involves learning from labeled data to predict outputs for new inputs. The model is trained on input-output pairs and learns to map inputs to correct outputs. Unsupervised learning works with unlabeled data, finding patterns and structures without prior knowledge of the output. The model discovers hidden patterns or intrinsic structures in the data. Reinforcement learning is about learning through trial and error, receiving rewards or penalties. An agent learns to make decisions by performing actions in an environment to maximize cumulative rewards. Supervised learning is the most common type of machine learning. In supervised learning, the model learns from a labeled dataset, meaning each data point has a corresponding output or correct answer. The goal is for the model to learn a mapping from inputs to outputs so it can predict the output for new, unseen data. Think of it like a student learning with a teacher providing the answers. Key characteristics of supervised learning include: it requires labeled input-output pairs for training. The goal is to learn a mapping function from inputs to outputs. The model receives immediate feedback during training, allowing it to adjust its parameters. Common algorithms used in supervised learning include linear and logistic regression for predicting continuous values and binary classifications, decision trees and random forests for classification and regression tasks, support vector machines, SVMs, for classification problems, neural networks for complex pattern recognition tasks. Examples of supervised learning applications include image classification, spam detection, and price prediction. Unsupervised learning deals with unlabeled data. Here, the model tries to find hidden patterns or structures within the data on its own, without any prior knowledge of the output. It's like a student trying to understand a subject without a teacher by finding connections and groupings in the material. Key characteristics of unsupervised learning include: it works with unlabeled data where no target output is provided. The goal is to discover hidden patterns or intrinsic structures in the data. There is no external feedback during the learning process, making evaluation more challenging. Common algorithms for unsupervised learning include clustering algorithms like k-means, hierarchical clustering, and DISCAN, which group similar data points together. Dimensionality reduction techniques like principal component analysis, PCA, and TSNE, which reduce the number of features while preserving important information. Association rule learning, which discovers relationships between variables in large datasets. Autoencoders, which are neural networks used for feature learning and data compression. Applications of unsupervised learning include customer segmentation, anomaly detection, and topic modeling in text analysis. Reinforcement learning involves an agent learning to make decisions by performing actions in an environment to maximize a cumulative reward. The agent learns through trial and error, receiving rewards for desirable actions and penalties for undesirable ones. Think of it like training a pet. You reward good behavior, and the pet learns what to do. Key components of reinforcement learning include agent, the decision maker or learner that interacts with the environment. Environment, the world with which the agent interacts and which provides feedback. Actions, moves made by the agent within the environment. Rewards, feedback from the environment indicating how good or bad an action was. Reinforcement learning has been successfully applied in various domains, including game playing, such as AlphaGo learning to play Go by playing against itself. Robotics, where robots learn to navigate environments or perform complex tasks. Resource management, optimizing allocation of limited resources. Autonomous systems like self-driving cars learning to make decisions in traffic. The power of reinforcement learning lies in its ability to learn optimal behavior through experience, without requiring explicit programming of the solution. We've covered a lot in this first module. Let's summarize what we've learned. We defined artificial intelligence and traced its evolution from early concepts to modern applications. AI refers to the simulation of human intelligence in machines, and its history spans from philosophical inquiries to today's advanced systems. We explored the three types of AI: narrow AI, current, general AI, theoretical, and super AI, hypothetical. Understanding these distinctions helps set realistic expectations about AI capabilities. We examine machine learning as a subset of AI that enables systems to learn from data. Machine learning is at the core of most modern AI applications, allowing computers to improve through experience. We studied the three main paradigms of machine learning: supervised, unsupervised, and reinforcement learning. Each approach has its unique characteristics, algorithms, and applications. Coming up in Module 2, we'll dive into Python for data science and AI. You'll learn essential programming skills and tools for building AI models, including Python fundamentals, NumPy, pandas, and data visualization. Get ready to get hands-on with practical applications.